So today we'll be dealing about the basal ganglia pathways, which is clinical significance in case of Parkinson's disease and in cases of something like hemibalismus. So before going into the basal ganglia papa, first we have to understand how the basal ganglia is plays the action during the muscle or motor movement. This motor cortex always stimulates the basal ganglia, and this thalamus always stimulates the motor cortex. So the stimulation of or increase in motor activity of is depends upon the basal ganglia stimulating or inhibiting the thalamus. So this basal ganglia can excite or it can inhibit the thalamus. If basal ganglia excites the thalamus, what happens is there is all positive, which means the overall summation remains positive. So this positive means increase in motor activity. Okay. If it remains negative, if the basal ganglia inhibits the thalamus, there is the overall sum or multiplication becomes the negative because there is the negative in between. So it becomes negative. This negative implies that there is decrease in supply or inhibiting. The thalamus is inhibiting the motor cortex, and there is decrease in motor activity. By knowing this, let us dive into the basal ganglia papa. So there are two main pathways by which basal ganglia operates. These are direct pathway and indirect pathway. In direct pathway, there is striatum, caudate nucleus, and putamen, and which inhibits the internal segment of globus pallidus, and this globus pallidus internus also inhibits the thalamus. So the overall summation remains positive because this inhibits this from inhibiting this. That means negative into negative is positive. So the direct pathway stimulates the thalamus, which stimulates the motor cortex. So there is increase in motor activity from the direct pathway. And in indirect pathway, there is external segment of globus pallidus, which inhibits the subthalamic nucleus, and interesting part is the subthalamic nucleus excites the thalamus, stimulates the thalamus. So the overall process remains in this indirect pathway is negative into positive, which is negative. This negative implies that there is decrease in motor cortex activity. So there is a decrease in motor activity from the indirect pathway. So what we have learned so far is this direct pathway disinhibits. Direct pathway disinhibits, which means it excites, but this indirect pathway inhibits the stimulation of motor cortex. So the clinical significance of this pathway is whenever there is Parkinson's disease, there is decrease or damage to the projections from the substantia nigra to direct pathway and to indirect pathway. Normally, this direct pathway is stimulated by D1 receptor and indirect pathway is stimulated by D2 receptor. The stimulation of D1 pathway or direct pathway disinhibits the overall system, means it increases the this system, this pathway means there is the motor activity is intact, and stimulating this indirect pathway means the inhibition is intact. Whenever there is damage to these projections, dopaminergic projection to the direct and indirect pathway in Parkinson's disease, there is a decrease in D1 receptor activation and D2 receptor activation, which means this direct pathway is now inhibited and this indirect pathway is now inhibited. So inhibition of direct pathway means there is decrease in motor activity. Inhibition of indirect pathway means there is inhibition of indirect pathway. So the bradykinesia and rigidity is explained by this mechanism in Parkinson's disease. And there is something called hemibalismos. In hemibalismos, there is damage to this ophthalmic nucleus. Damage to this ophthalmic nucleus means this whole process, this pathway, the indirect pathway is gone from the system. Whenever this pathway is gone from the system, there is unchecked stimulation of this direct pathway. So whenever there is the unchecked stimulation of this direct pathway to the thalamus, means there is uncontrolled activity of uncontrolled muscle activity because of overstimulation of motor cortex, which is explained by this pathway in case of hemibalismus.